Welcome to this presentation on redox titrations part 2. In an earlier presentation on redox titrations, we had seen an introduction to redox titrations. In this part, we will study an example of how the redox reaction works. Let us weigh carefully an amount of oxalic acid, say 0.2585 gram. Then we dissolve it in approximately 100 ml of 0.5 molar sulfuric acid. The exact volume is not important because we are concerned only with the amount of dissolved oxalic acid and not with the concentration. Next, we place an aqueous potassium permanganate solution of unknown concentration in a burette. Then we slowly add the potassium permanganate solution to the oxalic acid. Now the purple color of the permanganate ion will disappear as the reaction occurs. Now we have to do the reaction, that is continue the addition until a faint color will persist. Now this will indicate that all the oxalic acid has reacted with the permanganate ion. So when all the oxalic acid has reacted, the permanganate ion is no longer being reduced, and let us see that 22.35 milliliters of potassium permanganate solution is required to be added. Now look at this figure showing the three conical flasks marked A, B and C. Now in the figure marked A, a precise amount of oxalic acid has been weighed and dissolved in aqueous sulfuric acid. In the figure B, the aqueous permanganate of unknown concentration is added from a burette. Now this is continued until the situation in C arises. That means the purple color persists, indicating that all the oxalic acid has been oxidized. Now let us come to the calculations. We have to calculate the molarity of the permanganate solution. So we need to find the number of moles of permanganate present in 22.35 milliliter of solution used for the titration. So to calculate this, we have to take the number of moles of oxalic acid that react with the permanganate ion using a gram to mole conversion with a molar mass of oxalic acid as the conversion factor. So we calculate the moles of oxalic acid, which is 2.871 into 10 to the power minus 3. Then we know that 5 moles of oxalic acid is reacting with the 2 moles of permanganate ion. So the moles of permanganate can be calculated as 1.148 into 10 to the power minus 3 mole. Now we have to calculate the molarity of the permanganate solution. So we get the molarity as 0.05136. Now this is the molarity of the permanganate solution. We have come to the end of this presentation with an example for a redox titration, that is the permanganate solution and oxalic acid in aqueous solution. Thank you.